people said they couldn't hear from my computer, that there was this horrible sound. Oh, the graphics card of my computer apparently had died, but it came back to life this weekend. It's been working fine. Yeah. What? Yep. Okay. So here we are. We're going to do this page today, examples 5 and 6. They take a little while. This is going to be the most difficult content for your test. Okay. The first one is not that bad. The second one's a little bit more challenging. But the other classes have done very well so far. So hopefully we're good to go. You're going to want out your unit circle basic sheet so you can reference, quick numbers like sine of 3 pi over 2, stuff like that. Okay. Okay, so the idea is if we want to take a complex number and raise it to a power, how can we do that quickly and efficiently? And it all starts by taking a plus bi, whatever the complex number is, and putting it into trigonometric form. And so from Friday's lesson, you should be able to place any number, complex number in a trigonometric form. And so we'll actually, as we write the formula, first we'll start with this example. Find 1/2 plus 1/2 I to the 10th power. That would be very challenging to multiply that out 10 times. We can do it quickly. And we start by placing it in a trigonometric form. So I'm going to start by finding r and theta. So r is equal to the square root of a squared plus b squared. What is a squared? 1/4. What's b squared? 1/4. A fourth plus a fourth, a half. So the square root of 1/2, which is 1 over the root of 2, which is the root of 2 over 2. So r is the root of 2 over 2. Any questions how I got that? Okay. Then we got to find theta. Tangent of theta is equal to, we said b divided by a. What is your b value? Half divided by your a value, 1/2. What's a half divided by a half? 1. So tangent theta is equal to 1. Which quadrants is tangent positive? First and third. Is this point right here in the first quadrant or the third quadrant? First, because you're over a half and up a half. So that's how you know you're in the first. So therefore, we know that theta is equal to 45 degrees, or if we're in radians, pi over 4. So we've done the first step to DeMoivre's theorem, which is we place this in a trigonometric form. So we know that this is the same as the root of 2 over 2 times the cosine of pi over 4 plus I sine of pi over 4. And that's that. That's our first step. That's what we did last time. And then we learned how to multiply them and divide them. Well, now we're going to take them to a power, z to the nth. If you take this and raise it to the nth power, it ends up being whatever your r value is. You raise that to the n. You multiply by cosine of theta times n. So you raise r to the nth, you multiply angle by n. That's all you do. So think about this. We could multiply this out 10 times, which would be absurd, and we would most likely make a mistake, right? I mean, I'll tell you right now, if I had to bet on the chance that I would make a mistake on this, I bet, probably 50% of the time, multiplying this out 10 times, I'd make a mistake. I mean, probability is very high that you're going to do something wrong. Well, if we use DeMoivre's theorem, we ain't going to make a mistake. DeMoivre's theorem says you take r, which is the root of 2 over 2, and you raise it to what power? 10. Times the cosine of, what's theta? Pi over 4 times 10. What's pi over 4 times 10? 10 pi over 4, which is 5 pi over 2. If you want to leave it like this on your test, I'll say okie dokie. I can't stand writing it just like that. I like to simplify it a little bit. So I'll show you the other ways to write it. Because if you multiply this out 10 times, you kind of want to see something that doesn't have a sine or a cosine in it. And I'll show you how you get that. Okay. So you can write it like this, or I'll show you a way to simplify it. Follow this very carefully. If I have a fraction to a power, I take the top to the 10th power and the bottom to the 10th power, correct? This is 2 to what power right now? 1/2. If you have a power to a power, what do? Multiply. So instead of 2 to the 1/2, I could write this as 2 to the 5th over 2 to the 10th. I'll write it out and erase it. This is 2 to the 1/2 to the 10th. And at the bottom I have 2 to the 10th. So this becomes 2 to the 5th over 2 to the 10th, which is 1 over 2 to the 5th. 2 to the 5th is 32. So the back of your book would probably write this as 1 over 32. Now watch this. The cosine of 5 pi over 2. Is 5 pi over 2 more than once around the circle or less than once around the circle? More than once. Watch this. 1 pi over 2. 2 pi over 2. 3 pi over 2. 4 pi over 2. 5 pi over 2. 5 pi over 2 is the same as what? 90, which is pi over 2. So instead of writing 5 pi over 2, your book would write just 1 pi over 2. And if you still don't like that, what is the cosine of pi over 2? What's the cosine of 90? What's the sine of 90? 1 times I is I. So you get 1/32 times 0 plus I, which is 1 over 32 I. So you're wondering, what do you get when you take that and raise it to the 10th power? You get 1 over 32i. Ideally, I would like you to be able to express it like that, and like that, and like that. Like you'd be able to understand that all three forms are the same thing. I'll accept either or. Okay? Just want you to be able to raise it to the 10th and then multiply the angles. That's all I'm asking. Okay? But you do see why that's kind of nice to see, don't you? I mean, that's what you get if you multiply it out 10 times. So if we FOIL that out 10 times, that's what you're going to get. Okay? We took theta times n, and theta was pi over 4, and we multiplied pi over 4 by 10, you get 10 pi over 4, which reduces to 5 pi over 2. Question. Do you agree that the square root of 2 is the same as 2 to the 1/2? We're going to raise that to the 10th power. Power to a power, what do? Multiply. 1/2 times 10. It's going to be 5. Bottom, the power is 1. 1 times 10, 10. 2 to the 5th over 2 to the 10th is 1 over 2 to the 5th. 2 to the 5th is 32. So you got 1 over 32. Like I said, I'm not going to... If you don't want to go to that spot, you don't have to. If you just want to leave it like it was at the beginning, if you want to leave it just like this, that's fine. Okay. But you should understand the back of the book probably won't leave it like that. They'll do one of these two. They might write them both. Okay. That's DeMoivre's theorem. Raise r to the nth power and multiply theta by n. Good to go? Okay, then let's do the harder problem. And that is finding nth roots of complex numbers. So the example we're going to look at is, gosh, there you go, third roots of negative 27i. So what that is the cubed root of negative 27i, or negative 27i to the 1/3 power. That's what we're trying to do. So instead of raising it to an integer power, what if it's a fractional power? Which raises the question, what's the square root of I? You could answer after today what the square root of I is. You'll be able to figure that out. Nope, it's not 1. Find the third roots of that. Here's the formula that you use. The formula is going to look horrible, okay? But we'll make it look real nice. W sub k is equal to r to the 1 over n times cosine of theta plus 2 pi k divided by n plus I sine of theta plus 2 pi k. That's looks worse than it is. Not very many numbers in there, is there? I guess we got to write 2, but that's about it. Okay, before we start, does anybody know what you would multiply by itself 3 times in order to get negative 27i? Can you come up with a number? Yeah. What is what? Oh, fork. 4k equals. Oh. Wow. Sad day. No. Try. It's 3i. But there's actually 3 solutions, and I dare you to come up with the other 2. Here's what you do. Here's how you do the problem. This is the most important step. Identify n. N happens to be whatever root you're trying to find. So we're trying to find the third root, right? So n is going to be 3. Second of all, we have to identify k. Super important. For k equals 0, 1, 2, 3, all the way up until n minus 1. What is n minus 1? 2. So k is going to be all those numbers up until n minus 1, or 2. That's what n is. K will be the numbers 0, 1, and 2. I could have written 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, all the way up until k minus 1. Let's suppose we were trying to find the 8th root. Let's say you're trying to find the 8th root. What would your k values be? 0, 1, 2, 3, 4, 5, 6, 7. You always stop 1 short of n. Okay? Here's what these mean. We have 3 solutions to that problem. If it was the fourth root, you would have 4. If it was a square root, you'd have 2. And we will use these integers, 0, 1, and 2, in order to find the solutions that we're looking for. Okay? That's there. Now, first step is to take it 0 minus 27i. So that's what negative 27i is. And first, in order to make any progress with this, we have to put it in trigonometric form. What is the a value for 0 minus 27i? 0 is a. Yep. What's b? Negative 27. So, if you're putting it in trig form, you got to find r and theta. R is equal to the square root of, what's a squared? 0. B squared, I have no idea. Well, what's going to happen if you take 0 plus negative 27 squared and take square root of it? What are you going to get? You get 27. Yes. Yep. So r is equal to 27. Let's find theta. Tangent of theta is equal to b divided by a. What's b divided by a? Anything divided, yes, anything divided by 0 is undefined. Where is tangent undefined? Yep, 90 and 270, or pi over 2 and 3 pi over 2. If our number is 0 minus 27i, which one is it? Pi over 2 or 3 pi over 2? 3 pi over 2. So I have my n, I have my k. Now I've got my trigonometric form. My trigonometric form is 27 times the cosine of 3 pi over 2 plus I sine of 3 pi over 2. Can't do the problem if you don't set those up. Anybody wondering how we got any of this right here? Because if you plot the point 0, negative 27i, you go 0 units on the x-axis and then negative 27 units on the vertical axis. So we go down 27, so that's going to be 3 pi over 2. Okay, let's do it. We got to use our formula now. The formula says w sub k. So w sub, what's our first k value we're going to use? 0. So w sub 0, that's my k value, equals r. What's r? 27 to the 1 over n. What's n? So we take it to the 1/3 power times, what's theta? 3 pi over 2 plus, it says 2 pi k. What is our current k value? 0. What's 2 pi times 0? 0. Divided by what's n? 3. No, you guys. Ugh. Somebody's got to stop me when I start doing stuff like that. You tried? Okay, what's 3 pi over 2 divided by 3? So remember, when you do this, because you're going to do this a lot now, 3 pi over 2 divided by 3 over 1. You'll multiply by the reciprocal, so you multiply by 1 over 3, and you'll get just pi over 2, right? So we have, and what's 27 to the 1/3? What times what is 27? 3. So you got 3 times the cosine of pi over 2 plus I sine of pi over 2. Yes, Miss Martinez. Because 3 pi over 2 plus 0 is 3 pi over 2. Just to show you that we came up with 0. Yeah. My bad. You can leave it like that. Or what's the cosine of pi over 2? 0. What's the sine of pi over 2? That's the number you multiply by itself 3 times to get negative 27i. There are how many more solutions? 2. Ramp up. Get ready. 2 more. We just did 0, right? Smaller than. W sub 1. We just did W sub 0. Now we got W sub 1 and W sub 2. We start with R to the 1 over n. What's R to the 1 over n going to be every time? 3. Ooh, that saves some time. Times the cosine of. What's our angle? 3 pi over 2 plus 2 pi k. If k is, what is k right now? K is 1. So plus what? 2 pi. Over 3. Plus I sine of. Now, as Taylor said before, we write the same thing, correct? But instead of writing the same thing, let's use it as a chance to simplify a little bit. 3 pi over 2 plus, instead of 2 pi, I could write it as nine common denominators. What, Holly? Instead of 2 pi, we would have. Okay, you're a good man. 4 pi over 2, right? 2 pi is the same as 4 pi over 2, right? I'm just rewriting it so we can save some room. Great, I got it all plugged in. What's 3 pi over 2 plus 4 pi over 2? 7 pi over 2 divided by 3 over 1. Multiply by the reciprocal and you get 7 pi over 6, right? We get 7 pi over 2 divided by 3 over 1. Cross off, multiply by 1/3. We get 7 pi over 6, right? Yes. Because we plugged in our formula. And our formula says we take 2 times pi times k. And we chose k to be 1 for this one. We're doing W sub 1. It was 0 before. Okay, so we write it out. 3 times the cosine of, you guys told me 7 pi over 6 plus I sine of 7 pi over 6. You could leave your answer like that. Or you could write your answer like this. This is the way I like to write it. What is the cosine of 7 pi over 6? Negative root of 3 over 2. What is the sign of 7 pi over 6? Negative 1/2. And when you multiply through, you get negative 3 roots of 3 over 2 minus 3 over 2i. Now, I know what some of you guys are thinking. If you multiply this by itself 3 times, what should you get? What should you get? Negative 27i. We just found the third root. Now, you're wondering if you actually multiply it out 3 times if you get that, wouldn't you? So that's what you're going to do tonight. You're going to go home and you're going to say, I'm wondering what I really get that. You're going to multiply it out. That's what I did, and I did get negative 27i. Emily Ortiz. I would back up here. You want me to back up there? I don't know. I'll let you know study guide day. How's that? Because last year I made them write it like this. Everybody was made to write it like that. Yes. Yeah, I would never do that to you. Yep. I mean, I know I'm mean on the outside, and I look scary with this beard. But no, I would never do that to you. Yeah, so if you had, so like one of your problems out of your book is to find the 8th root of I. Not for your homework, but that's one of the questions. What's the 8th root of I? So there's 8 solutions. You'd have to do it 8 times. No, it wouldn't. It wouldn't. It would be so fun. You would be so much better off for doing it. Life would be grand, right? All right, I get it. It's a lot of work. You don't want to put too much in. I got it. I got it. So, but let's just at least be able to find square roots, cube roots. There is 1/4 root on your assignment. Hopefully that's an easier one. But let's do W sub 2. So we've chosen K to be 2. That's our last one. And it starts off the same. What is R to the 1 over n? 3. You got that. Times, parentheses, cosine of, what's our angle? 3 pi over 2 plus 4 pi. Yes, 2 pi k. And 2 times pi times k is 4 pi. Divided by 3. Plus I sine of 3 pi over 2 plus 4 pi over 3. Oh, I didn't simplify any of this. 4 pi, rewrite it so you have common denominators. 8 pi over 2. What's 8 pi over 2 plus 3 pi over 2? 11 pi over 2. Divided by 3. 11 pi over 6. If you want to be done at this point, you can. Or, if you're like me, what is the cosine of 11 pi over 6? Root of 3 over 2. What's the sine of 11 pi over 6? Negative 1/2. And so if you multiply that, you get 3 roots of 3 over 2 minus 3 over 2i. Because we had an extra week, because we didn't have 6 stinking snow days. And I like you guys more than last. Yeah, it's out there. It's out there. Yep. Yeah, I'm sure they go back and rewatch the pre-calculus videos just to see what I say about them. All right, so again, if you multiply this by itself 3 times, you get negative 27i. This by itself 3 times, you get negative 27i. And this by itself 3 times, you get negative 27i. We answered a very difficult question. Now, you could find the square root of I. It would be, piece of cake. Upside down. So, here's your assignment. You guys are going to hate me when I do this. I only have 3 DeMoivre's theorem problems for you. And then I have 3 of the nth root ones for you. But one of them is just a square root. So, if it's a square root, how many times do you have to do it? Just twice. And another one's a cube root, so you just do it 3 times. And the other one's 4th root, like 4th root of I or something like that. You do 4 times. But hopefully you should notice a nice pattern that develops with them, and hopefully they should go really smooth. This will be the most difficult content for your test. Right now, you guys, it looks like next week, Wednesday or Thursday, right around there, is when we would be able to test on this stuff. So we also have to talk about vectors, polar coordinates, and parametric form. So those are 3 topics that are entirely new to you that we need to do. We're just going to do the bare bones of them. So. Okay, let me pause this. Actually, stop.